video quality. So I'm not really expecting this to have made much difference. I'm still not 100% sure about the drive format or anything with this. I might give a go. I've got bear with me. I've got a spare GoTech kicking about, so I might have a little look and see if getting one of those set up would work. But I don't see why the known good drive I've already tried wouldn't work. But I'll certainly retry the others anyway to see if this has made a difference, and if not, I might have to start poking about. There is a possibility that the controller chip, which is incredibly rare and I won't be able to get a replacement, has failed, and there is an alternative to it. I think it requires a slight change to the circuit board or the ROM or something to get that working. But let's give a floppy a go again, see if we can make any progress. I'm beginning to suspect I might have an issue with the TMX 9909 floppy controller. We've got it in boot mode, which means that the drive is constantly trying to seek to try and find track 0. Now the user guide says check on pin 5 of IC70 over here for a 2 US wide 50% duty cycle. If you have a look at what we've got there, that is 2.2 US, so sort of close enough. And then the other thing it says is that check that the RKM at pin 26 of IC76 is phase locked with the above signal, and there is absolutely nothing on that pin. So I'll have a look at the tracing, but it does appear that there is definitely some kind of issue here, because if those two signals are supposed to be the same, or at least picked up here and picked up there, then that does suggest that there is a problem. So I'll dig a little bit into that. If it is that chip, it's pretty much impossible to replace, because there's the TMX there, which was effectively a prototype rather than the TMS. Very rare. So I might have to investigate what the alternative floppy controller is and see what changes need to be made to the board to accommodate that. I think even that chip's relatively rare, but first of all I'll see if there's anything obvious. If I look at pin 2 of 87 here, which is clock, and if I just scope it directly, we've got nothing, just ground. And if I pop it back in again, making sure that I am the right way up, and then power back up again, and we'll set it to boot. And then if you have a look again at pin 2 here, sorry, of 87, I'm on the wrong chip, which is this one. We've got this kind of weird floating, and that's supposed to be the clock signal that's being fed into, and that comes out of 86, which is the one directly above it. So something isn't happy. So what I've had to do here is I've got the 74297, and the retro chip tester can't test that because it is a digital phase locked loop filter, whatever that is. So I've grabbed the schematic for it here, and you can see there's a whole set of diagrams. There's a little thing here which shows that the A, B, C, D, high, low, 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 2 to the power of 3. Now that should be impacting the output, I presume, on ID out, and we've got two other inputs here as A1 there and the B input there, which we can see on here. Now what I've done is I've set up the circuit as here, so you can see here A is held high, B, C, D all held low, and then we've got the two inputs which I'm not currently set up coming in from here, from IC 70 and 87. But what I can do is check the output on pin 7. So got a real basic little setup there with a 7404 and a crystal kicking out the 12 megahertz signal that it says it should have, which we can see there. So we've got that coming in fine, and if we check pin 7 we can see that it's output something. Anyway, so I'm gonna guess this is working. The two pins that I've got here are going into those two inputs, and if I set them high or low I can see change on the output there. So I'm gonna make the assumption that this is okay, and what I need to be looking at is the IC 70B or the two that are over here, or actually it could be any of those three that are interacting with those two lines, which are currently doing absolutely nothing. So let's pop this back together and try and work out what's going on. Right, then I'm going to have to pull the board off and double check some of the traces. So over on this side, pin 1 should be going to ground, doesn't seem to be. On this bit here, the sort of handwritten pin numbers on that suggest that that should be pin 5 going up to the not RKM on 26, which it isn't, but 7474 on the second circuit, Q's actually pin 9, and 9 does go up there. So the schematic works, just the pin number's wrong. And then the other thing that looks a bit weird is here you've got this flip-flop. So you've got the circuit A and the circuit B, and the circuit A feeds into B, so D to Q, and this says 12 to 8, and 12 to 8 isn't connected, but D to Q would be 2 to 9, which isn't connected either, and 12 to 8 would be circuit B, D to not Q, so it's all a bit odd. I'm fairly sure there's some cut traces and some rewiring going on underneath the board around this sort of area, which I've left as it was, but I might just have a little look and see what that's actually changing. That was my fault. So pin 1, which is up here, I just hadn't soldered the pins. I've done all the sockets here at once and I just missed those two. So that's a nice easy fix on that side. And then the mystery of this is that that's got D in the A side, so D1 to Q2, which I thought was 2 and 9, and then here we've got 12 and 8. And if we actually have a look at what's happening on the board, we've got this little bridge here, and that bridge there goes from 5 over to 12, which is the other way round. So that's Q1 to D2, not D1 to Q2. So I think this is just a misprint. Otherwise that trace is completely wrong and needs swapping. So I think that's a misprint, and then someone's also put the wrong pin numbers on it. So I'm going to assume that's actually okay. That's a misprint, and that's fixed. So I might just pop this back and see if I'm getting anything different now I've actually fixed one of the issues with that. Right, well, So that's seeking, and if I have a look at 26, we now do have a signal. So that's progress. Interestingly, I'm sure on pin 5 I was seeing a proper seek on track 1, I think it is. So that should be pulsing, which I was seeing before, and I'm not seeing that now. I mean, it could be that the floppy just isn't finding track 1, but that's at least some progress. So I can now see activity on both IC70 on pin 5 there, which does look like that would match the phase lock signal which it's looking for on here. I could connect the other probe up and then check them, so I might do that, but that's at least some progress. So I think what I need to do now is to just actually run a test and see if I can get the floppies to do anything before I start trying to look for an issue, because it could be that that was what the problem was in the first place. But we'll give it a go, and I'll see where I get to. Actually, there we go. We can see the pulse on pin 5. Just had to adjust the scope a bit. So that's good. Right, let's see if we can write something to the floppies. So this is just showing that the grease weasel does seem to be able to write to the floppy. Still trying to look at this floppy. So this document here says that what I want to do is to check on pin 5 of IC70, and that should be 2 U-sec wide 50% duty cycle is what it says. If you measure the sort of data there, that says 2.3 US, and it says adjust resistor R70 to being within 5%. Now R70 is this one down here, there. So it's not exactly a variable resistor, but I'll try, I'll attach another resistor on top of that to drop it and see which way that goes. Otherwise I'm going to have to pull it out and maybe put a varistor in it or something, just to try and dial this in. I'm not entirely sure that's what it is, but it does say within 5%, and 2.3 isn't within 5% of 2. So I'll give it a go, see if it makes any difference. A 51k resistor connected alongside gives me, that's the distance between, which is almost exactly 2, and that's the distance there, which is pretty much bang on 2. So that's now set to exactly what it should be, and a 51k on top of the 12k that's already there is about, well, it's just a bit under 10, it's about 9.7k. So I could swap that out and that would set it exactly to where it was, but that is making no difference at all to my little Gotek, which is just sitting there trying to boot, between track 0 and 3, backwards and forwards, so it's still unable to boot. I might swap that resistor out anyway, so it's fully within spec, but it doesn't look like that was the problem. Here we go, just checked a 10k in, which is near enough, and if you have a little look here, so that's 2, so we've got pretty much a 2 US gap there, and that is pretty much 2. So that's 2 US 50% duty cycle, which is exactly what it says I should get. Okay, let's look for something else. I am going to dig into this, so I'm going to make sure that I am happy that this floppy, at least one of the two floppies, is working using the grease weasel. So the first thing I'm going to do is I am going to run an RPM test. So that should spin it, should read the speed of the disc, and then I can adjust it using the little adjustment here to try and get the speed as close to 300 RPM. So if we give that a launch, that should start firing up. Yep. And there we go. We can see that that's 305, so it's spinning a little bit fast. So let's get that in there. You can probably hear that slowing down. So we're 9, so if we get that up to there, that's close enough. So that's now spinning at 300. Right, so we've done a read. I don't know quite what that is, so that says it's found 640 sectors of 640. And it seemed to read. So I guess I'll have a little look and see if the image that it's written looks anything like the image that it's read. So let's have a little look. Oh, well that's promising. So there's the image that was written, and we can see here, MDEX system disk, and here's what it read, exactly the same. So that definitely shows that this disk drive and the floppy that's in it can at least read and write using the grease weasel. So I think the next step is to pop this back in the Cortex, and then we'll start having a look and double checking that that the pull-up resistors are working as expected, which they should be, because otherwise this, I guess, probably wouldn't work. I'm not sure whether this has got pull-up resistors on the input and output like some controllers have. So let's get this hooked up, and then we can monitor and see if actually we can see any data coming back in when it tries to do a boot. We're back on the bench. So got the schematic up, and if you have a look here, so pin 30, which is where the data comes back in from, so that's IC84 pin 16 coming in there. So that one here, IC84, so that's 10. So 11, 12, 13, 14, 15, 16. So if we boot, I really do need to get VGA out, because yeah, that is pretty wobbly. And we try and boot it. You can see that that's bouncing backwards and forwards, trying to locate the first track. So 11, 12, 13, 14, 15, 16. And we can see down there that we are already seeing something. So that's the data that's coming in. We can see with it trying to identify where to start. So what I need to do now, I think, is sit here and run through all of the pins, make sure that everything's connected in the main circuit. So where it all comes in, it seems to pretty much all route through here, and then we'll try and work out whether we've got a problem. Joy. Okay, well that's a bit weird. So if this is correct, we had a look at pin 16 here, which should be where the data's coming in from, and then pin 5, so 1, 2, 3, 4, 5 should be the output, and we're getting that. Oh, interestingly, I think bridging that made that go a bit funny. 1, 2, 4, 5. So what does that look? We're going to have to have a look here. What have we got? So we've got a few things connected to that. those should be inputs. IC88. Right. Okay. So just initially, having a look at that, directly on pin 16, we've got R71, 150R resistor, so that should be a pull-up resistor. And that should be to 5 volt, I would have thought. Yet we're only seeing 3.68 volts on that. So that looks almost like something's pulling. I've unplugged the floppy as well, just in case that was causing an issue there. But, that seems a bit weird. Why wouldn't that be 5 volt? Let's have a look. So I've done a bit of troubleshooting, running through the chips here against the schematic. And actually I haven't found anything wrong yet with any of the connections here, so everything does seem to be going where it's supposed to be. I have noticed a few issues with the actual diagrams we've got here, like there's a couple of flip-flops here, and for example that's got IC88A and B, and normally with most of these the A and the B's, like the 1 and the 2 for the two sets of circuits, so that would be like D1 and that would be D2, but in this case A is the secondary circuit, so that's Q2 and D2, and B is the primary one, so Q1 and D1. And actually here where we've got pin 12 going to 8, that's not right, because that's Q1 on the flip-flop, which is pin 5. When you look at that being 12 and 5, that's all okay. So the diagram's okay, the pin numbers are wrong. Similarly here, the pin number which originally got me thinking I had a problem was pin 16 being pin 30 to the floppy, but actually it's pin 15. There's a couple of other ones I don't think are an issue. Like it's got the drive selects here as 1, 2, 3, 4 on 6, 14, 12 and 10, but that's backwards. Does seem to work though, so I think that's just a labelling issue. And then the only other thing which I'm going to have a little look at is here on pin 14 for side, it says link to 32 on 5-inch, which is what I've got, and I don't have the side going to 32. Now that might not be an issue with these anyway, because these are single-sided, so they might not need that side signal, but I'm going to connect that up anyway, because that'll definitely stop any of the double-sided drive images that I've been trying to get on the GoTech working. So I'll give that a quick go. We'll link pin 14 to 32 and have another go with the GoTech, but I'm not holding out much hope on that being the issue, but we'll give it a go. Here we are, so just a little bodge wire going to the via that goes to pin 14 on the 8-inch floppy cable over to pin 32. So let's see if that makes any difference. I've been chatting to some of the guys on the Vintage Computer Federation forum, and one of the guys there happened to mention that I've perhaps been using an old version of the Cortex data transfer utility, and this one here which is sent up is version 1.3, and if we go onto this and do confor init, and then as long as it's at 300 baud, if we do the send command file, then what that does is that echoes there all the commands that I had to type out down the serial port. Then you can reset it, set yourself back up to a faster baud rate, and when you init it that time you can send one of the cassette images over like we did beforehand. Also, what he said there is he's got a disc formatted to 40 tracks using his Cortex, which should in theory be compatible with the floppy that I've got here, so that should at least tell me once and for all whether I've got an issue with the disk, the drive, or the Gotek, or my Cortex. And one thing which also I've had a read at one of the posts on the Flash Floppy GitHub, and there's a good idea on there, which is to read the floppy disk in through a grease weasel, take an image of it, then using that image, play it back through the Gotek again through the grease weasel, take an image of it, and then you can compare the two images, and you should be able to see whether the config that you've got for the Gotek is correct or not, or whether you've got something slightly out, and then you can tweak it to try and get it correct. So hopefully that disk will turn up soon, but in the meantime that util is going to save me quite a bit of time, because one of the reasons why I haven't really been trying to diagnose the format issue is because you've got to type those commands in every single time after you've reset it. So that was a bit galling. But right, I'm going to have a little play with that, and hopefully we'll have a floppy to test. Actually, I have just noticed a difference. So I've launched SA format, which is what we should be using to try and make a blank disk. And in the README that's come with this new version of the comms util, it does mention that it's got a new version of SA format with a bug fix in it. And now, if let's move the head. So if I manually pull the head away, previously it just immediately errored. So now if I say, oh, I really need to fix this video, yes to that, and we do enter, here we go. Right, we can see that seeks all the way back to the first track, and then it still aborts. So whilst it's still not working, that means I've now got exactly the same symptoms with the SA format as I have with the boot command, where the drive seems to seek all the way back to track 0, and then either it can't read what's there, or it can't see what's there, or it's not getting the signal to say that it's found track 0. So that's great. It's still not working at all, but at least that's a bit of progress. That now points to the same issue, and I can start to look at what that is. If it's not, it could be the drives or the floppy disk that I'm using. But yeah, progress. I've been sat in this very spot for 2 days, and behold, here we have. Footy track, CDOS 1.2. So the question is that going to boot? That out. Get the right way up. Or at least the way I think is the right way up. Oh, now that's interesting. That is a different error. Ooh. Right. Let me have a little poke, and I shall be back. I've just had a thought. This is a single density disk, which presumably is the density jumper. So let's pull this off. So So that's the density jumper done. I don't know if it needs to be rebooted. Let's reboot it anyway. Okay. No. That's doing exactly the same thing that it was doing before. Ah. Which presumably means that the density jumper does want to be on. Yeah. Let's pop that back on then. Not that. Okay, so some more testing. So I've imaged the floppy using the grease weasel, and I can get it to image using the standard like raw flux copy, but I can't get it to use the HFE v3. If I use the HFE v3 version, I get this track too long to fit in image. So not entirely sure what that is. But using the standard HFE image, I did manage to burn a copy onto another floppy disk, which is here, which boots. And I've also tried popping the image over onto the Gotek here, using just a fairly basic little config, just to say the mode's FM, 300 RPM, 250 rate, 40 cylinders, one head, 16 sectors, and 128 BPS. And I can see using the visual floppy function here from the HXC floppy emulator, and we can see the data. So we can see the sort of 4 and 8 US data streams coming in along here. So that's what these are, and we can also see the 16 sectors there across the tracks, and you can zoom all the way out. Is one of these ones? Which one's the zoom? Yeah, there we go. And if you go into one of these, you can also see over there, you can see the contents of the disk, and we can see some of the wording. There you go, controller error, which strangely enough is that controller error. So this will definitely work, at least using a raw image. I don't know whether the DSK ones will work. I can see the data on here using just the normal ISO FM. It doesn't know what the data format is. So I don't know how much this helps me. It does look like this is clearly booting. If we look at the manual for CDOS, all it says is floppy disk or drive error, really. And I think because we know that this reads and writes through the grease weasel, this in theory should work, but we don't know whether they've got the config right for it. So there is either something wrong with the CDOS config that's on this floppy, which I doubt I'm going to be able to change, unless I can perhaps boot the image up in the emulator or something and check the file or edit the file, or maybe there's something I can actually do directly in the raw image if it was just a case of changing a couple of bits around. But as it stands at the moment, I can definitely see that the Cortex can read and boot from the data that it's getting, but the program's then subsequently crashing, which is a bit weird. So I'm no further forward really, but at least I've got some more things to have a poke at. Okay, so I've had a couple of things to check from one of the guys on Vintage Computer Federation forums, and what he suggested is we use the mon command to get into the monitor mode. and that way we can actually check what the values are that we can see for the floppy disk controller. So one of the things which he suggested we went and had a little look at is to see what we get returned from this F140 command, and he's saying that F140 should be FF00, but we're seeing FFC7, so there's definitely something weird there. And then he said that we could also attempt to try and disable this check and do a boot, but we're still getting controller error on that. So I'll feed this back and see what he says, because I have no idea really what these commands do. I think we can look up the F140 in the manual for the floppy controller chip, possibly, and try and have a look at that. So I might have a quick look. The other thing he pointed out was that the strange inverse of the data line D1 is completely normal, and that is the idle signal. So it uses the first 3 data bits of 0, 1 and 2, and you'd expect 0 and 2 to be low, 0, and data line 1 to be high, 1, so 0, 1, 0 for the CPU idle command. So that's completely normal, that when we can see it's not doing anything, that's exactly what we would expect to see. So that's good. I mean, it didn't look like that was causing any issue, because it wouldn't boot if that was really an issue. So let's try and work out what this FFC7 means. Also, interestingly, I'm now booting off the Gotek, because I've just tried booting off the floppy, and I'm now getting a different message, like system failure, when trying to boot off the floppy drive. I tried both of the disks I did, and that was working absolutely fine. So we've got something weird going on with this now. I'm not 100% sure that the disk image is booting okay on that, which just adds another variable to it. But we'll go and have a look up at that and see if that gives us any ideas. I've got that doing a raw copy, which seems to be working. Right, so I've just done a quick test. I'm actually just using the Cortex to power it for the minute. So I have, let's not break that. I've got a BBC disc there, 80 track. Going through the grease weasel, and we've done a clone, and this is just a raw, and I can see here that I can see all the tracks. I can see the 2 data lines, see their LF main squashed, so I can definitely see the contents of the disc. Let's do a disc view, and I've only done the one side. I didn't know if it was double-sided, and yeah, it seems to contain data. So I'm going to say that this disc is possibly working, and I can get that popped back in its case if I want to keep it as an external caddy, or I might just use it for the Cortex to try and diagnose the problems. Oh my goodness. So what I've ended up doing is I have used the HXC floppy emulator, and I've done the load raw image, and I've set it up for an FM, 80 tracks, 128 byte single-sided 16 sector disk image, and then exported it as a raw image file, which I've then burnt to disk using the grease weasel. And that seems to, let's just do that again. So boot. We're booted. So I still don't know what's preventing the format tool from being able to format the disk, but that has just booted that floppy that I've made. So maybe I'll try making another floppy or two, but that's actually working. It lives. Still at it. So we've run the commands to have a look at what's going on, and we're now getting a CRC check. So I'm still thinking that we've got a disk or a drive issue, which I really want to get to the bottom of. So we've got here a BBC micro drive. Now this is an 80 track double-sided dual density drive, so I should be able to write any format of disk that this can accept using that drive. And I've got it up and running, and I can test it with the grease weasel, and I can read and write with it, so I think it's working, but I haven't actually seen it working on another machine, so that's a little bit of an unknown. So what I've started to have a look at is the disk that I can't write with this, which is the guides tell you to run the SA format a disk, then connect it up, then do a file transfer over to get the original boot disk running on it. Now we know from the guides that it's an 80 track single-sided single density drive disk, so 160k. We've got 80 tracks, one side, 16 sectors, and 128 bytes per sector. Now, if I try and load that image up with HXC floppy, it just errors. So if you try and open that, load error, doesn't know what it is. But if we go into the load a raw image, we can specify the type of image. So we've got it set to an FM, 16 sectors, 80 tracks, single-sided, 128 bytes. And if we load it in as a raw file this way around, it's not an IMG, then it will load this up. And if we then do a track analyzer on it, and if we have a look at the track 0, I can see the same information that I could see on the disk which I got sent, which is booting on a different Cortex but doesn't work with the drives that I've got. So what I've then done is I've used HXC floppy to save that disk, and I've saved it back as a HFE file, which means I don't need to worry about the config for it. I can just use the Grease Weasel app and do nothing other than the Grease Weasel write. I'm doing drive 0, which I might not even need, and then the HFE file. So I need a disk. So there we've got focus on it, a disk that should be okay. So if we plop that in here, and that is connected up. The Cortex is running because it's actually powering that drive at the minute. So if we launch that, assuming it can actually communicate, so there we go. So that's writing. Okay, you can see that writing here. You can see the head moving. We've just got to get to 80. Right, there we go. So, in theory, this disk now has the boot disk on that I can't get the Cortex to write, but I want to see if the Cortex can read it. So let's unplug this, and let's unplug this. I may need both hands, so I may need to, oh, there we go, put that down there, put that into there, shift that out of the way, give the Cortex a boot, and there we go. So What happens if I do that? Okay, it seems to be returning back from track 80. Oh! Gotcha. Right. Booted. So, I've got an issue writing, but I haven't got an issue reading by the looks of it, at least with this drive here anyway. Right, I'm going to have a little play because I don't actually know any CDOS commands. So I'll have a little read up on that because I almost wasn't expecting this to work. And I'll be back. Right, welcome to the Disco Colours. So apparently we have a program on here called Dur. Drive 0, please. There we go. Okay. So, I mean, I wonder how you get it to do a page at a time. So, yeah, we can see the disk image. We can see the SA format. We can see one called Hello. Yeah. No. But, okay, I'm not sure what that's doing. Let's just try exiting out of that. Ah, well, there you go. Very exciting. Okay, so that's working. I'm gonna have a play around, but what I think I'm gonna need to do is I need to go back to this because I was not looking at any of the write circuits originally. I was looking at the read circuits. So I'm gonna have a little look at this and try and see what I need to check next. To look at the write circuit. And also, this should boot off the Gotek because I don't need to worry about the config, because in the same way that I could just write that straight to the disk using Grease Weasel without using a config file, I can do exactly the same with the Gotek. That will boot it without the config file because it's just a raw disk image. So I'm going to give that a go as well. But let me pick this schematic apart a little bit, and we'll have a little probe. Right, so interestingly, if we try and run the CDOS rename, I get disk write protect error. So could the problem be that the write protect signal, which comes in here on pin 28, I believe, isn't working? So that's active when low. So if it's low, which it is, I mean, sort of scruffy low, but it is low. I mean, that looks, yeah, that is completely low. That's the same as ground. So if I got a short to ground, let's unplug everything. Yeah, unplug the drive as well. Yeah. So we don't have anything plugged in. And if I get my multimeter up, and we hook that on there, I mean, that's going to be pretty irritating if that is the problem. Right, let's look that up. Oh no, that's high. I had a short. Ah, I thought I checked absolutely everything. I'd made sure that that was connected up, that that went to pin 28. I'd done all of that. I'd checked through everything. Hadn't checked that the right enable pin is there. So if this is the problem, let's try and boot that up. Let's boot that into that. Um, good. Oh no. Oop. We have a file there called help me. Oh. Oh. Right. So I did have a right issue, but the just immediate crash was right enable, and it wasn't until I could actually get CDOS working and tried to do a write, just a normal file rename, that it actually told me that the disk was write enabled, which it isn't. And I know there's nothing wrong with the drives, so that's just pointed just immediately straight to pin 2 here, which comes in on pin 28, which is the write protection pin, which should be high or low if the disk's write protected, and it was stuck low because I had a tiny solder bridge on the underside of the board. So I think I can probably format a disk now. Okay, right, let's not erase my boot disk. Let's do that one. Okay, drive 0. Let's do double-sided, double density 80 tracks. Ah. Okay, let's just try a single-sided, single density 80 tracks. So maybe that's not the only problem I've got. Right, I'll do a little bit more digging and I shall be back. I've done nothing. Well, not strictly true. I was probing the W data line. I mean, it could just be that that floppy disk isn't that good, but that is formatting. Formatting complete. Format another disk. Do it again. Okay, that is formatting, and that's not me probing it. So it's quite possible that the disk is just a bit dodgy. Although I have written to that disk all right before in the past. Right. Okay, I'm going to try burning some disks using the PC interface, so the COM port, and see if I can't get a newer version of CDOS. Okay. Yep, that's going. So we've got the PC comms util here, sending it over down through the RS-232 port, and that is writing to the disk I just formatted. Right, well, I'm going to call this done. I never thought I'd say that. The video circuit is still awful, so I'm probably going to look at a modern replacement that I can get VGA out of, or at least RGB or something. There's a nice Pico project I might look at. I'm also, I think I'm not going to run this. I'm probably going to try and make a boot disk, just a basic boot disk that'll boot on this, and make a sort of fake front for that, for the Gotek drive, and then I can run a Gotek and an original floppy in it, and I'll keep the other one of these aside, which I'm not entirely sure it's working anyway. But right, yeah, well, I might have a little play, see if I can find anything fun. But I'm going to start to get this reassembled. Got my 5-volt LEDs here, and I've wired them up to a little connector. So that should mean now that for the first time in its life, it's actually got the front lights on. I'm not entirely sure how nice they'll actually be if you're using it like that, because you just have blinking lights at you the whole time. You can't really turn them off. That's probably why they were never connected. So that means that I can now unplug from here. There we go, my little temporary adapter, so that I could see what was going on with just some LEDs on, and then I can plug that into the header. So I'll get that plugged in, and then I'll get the rest of the chassis assembled with the floppies in. That's all together. So there we go. That's got the drives in there. And this is insanely heavy. So I'll connect the power up and try and screw this top back on. One moment. So there we have it, all back together and blinking away. Yeah, that's been a lot more work than I thought it was going to be originally. But I'm happy that we've got this back to a decent condition now, and hopefully this will be running for a good few years to come. There aren't many of these left about, so that's it's nice to get that one rescued. I'll probably do another video at some point where I'm going to try and get either the original RGB interface that I think there's some schematics for in one of the old magazines, or there's a more modern version that actually just replaces the graphics chip. I think it's using things like the Coco and stuff like that, which actually gives you like a VGA output, because the standard sort of PAL TV out on this is just dreadful. But anyway, I'm going to leave it at that. Thanks for watching, and I'll catch you later.